This time we're going to be doing an exercise where we have to be finding angles in right angle triangles using trigonometry. So here's the triangle we're going to look at for an example. In this case, we don't know this angle theta put in red, but we do know two of the sides. Again, we're going to have to ask ourselves which one of so, ka, or toa will be relevant for us. Are we going to be using sine, cos, or tan? Good idea to begin by labeling the sides of the triangle. This is the longest side, it's the hypotenuse. And then this side is opposite to my red angle theta. And this side is the adjacent. I know something about the opposite and about the hypotenuse. So clearly, if I know the opposite and the hypotenuse, more than likely it's going to be the sine value, the sine ratio I'm going to be interested in. As usual, we'll start with a formula. Sine theta is opposite over hypotenuse. Then we're going to substitute our values in here. Sine theta. Theta is the angle we're looking for, and the opposite is 10 centimeters, and the hypotenuse is 15 centimeters. Now, notice that, by the way, in this fraction, the centimeters here cancel each other out. Also, 10 and 15 simplifies to 2/3. So we could write sine theta equals to 2/3. That won't always be the case, that this simplifies. But now we have to solve this equation, and we're in front of a puzzle. What we're really asking ourselves is what value of theta will give me 0.666 etc. as an answer. Because 2/3 is 0.666, so sine of what is 2/3? Now I could try this out with my calculator. You can see that sine of 40 degrees is really close to that, 0.64, so it's not far from 40 degrees, but I don't want to be using trial and error. How can I work out the exact value of theta in this case? Well, the answer is that I'm going to have to do the other way around. I'm going to have to take that equation and find the inverse sine. I have to do the opposite of the sine function, and the opposite of the sine function is the inverse sine, written as sine to the power of -1. Sine to the power of -1 of all of this equation, that means I'll do the inverse sine of this, will give me theta. And then I need to find the inverse sine of 2/3. This is another special function on our calculator. Very often you will find this function really close to sine, cos, and tan. In this case, it's just above using the second function. In the second function, you see sine to the power of -1. So if we type that in, second sine, and then we do the fractions 2/3, 2 divided by 3, close bracket, and we enter, that will give me the answer for what value of sine theta is 2/3. And the answer is 41.8 degrees approximately. 41.8 degrees. Actually, this is an approximate answer, and I've rounded to 3 significant figures. In this case, this is the exact answer, and this is the approximate answer. And that's how I find angles in right angle triangles, using the inverse functions of sine, cos, and tan. So I have sine to the -1 of theta, cosine to the -1 of theta, and the inverse tan function is like this. Good luck!